In this video, we're asked to write a method called countMultiples that'll basically be added to our int_tree class. The method returns a count of the number of multiples of a particular value in a binary tree. Given a number n, a value m is considered to be a multiple of n if it can be expressed as k times n for some integer k. So let's assume that we have this binary tree here, and we decide to count the multiples of 2. So it's going to return a 6 because 6 is a multiple of 2, 2 is a multiple of 2, 8, 6, 4, and 0. Now if we call a multiple of 3, we see that we have 5 because 6 is a multiple of 3, 3 is a multiple of 3, 6 is a multiple of 3 again there. 9 is a multiple of 3, and 0 is also a multiple of 3. So then we call upon multiples of 1. All the 10 numbers are multiples of 1 because you can multiply 6 by 1 to get 6, 2 by 1 to get 6, and so forth. We should throw an illegal argument exception if the value passed is 0. We're allowed to use a private helper method, but we're not allowed to call any other methods in the int_tree class. We have access to the data field, the left and the right branches, and the overall root. So let's get started. Okay. Okay, so it's public integer because we're going to return a count multiples, and it's going to take an integer value that we're going to use to compare to. So if the value is equivalent to 0, then we said we wanted to throw a new illegal argument exception. Otherwise, what we're going to do is we're going to return a count. And we're going to do that by calling upon a helper method here. countMultiples here. Okay, sorry about that. countMultiples. We're going to take in an overall root so we can traverse through the tree, and then we're going to take in the value so that we can actually see the multiples of that value. So private integer countMultiples. Why is it of the type int? Because we're returning that value up to here, and that value is getting returned in turn. So countMultiples int tree node root int value. Okay, so let's deal with the base case. So what do we do if the root is equivalent to null? Well, in that case, we just return a 0 because there's no multiples of an empty tree. We have nothing to look at. So what's another case we could look at here? Well, the other cases we want to look at are just the nodes in general. I mean, we're not doing anything specific with the branches or the leaves, so we can just keep those all in the else case. So we need to keep track of a sum, and the way we're going to keep track of the sum is by adding the counts that we get from traversing through the left and the right subtrees. So we'll call upon a count multiples of root dot left with the given value plus count multiples of root dot right with the given value, and that'll be that. What do we want to do at this point? So we've declared a sum. At this point, our sum should be coming back and forth, traversing through the entirety of the tree. So now let's actually check the data points. So if we see that the data modulus, the value, is equivalent to 0, then we know it's multiple, and we just want to return 1 plus that sum. The other case is we just want to return the sum, and we want to keep looking through the entire tree until we hit a value like this, or we've reached the very last node that we could possibly reach. And that's it for this video.